Welcome to another exciting episode of the NIDS View, a weekly show of the National Institute for Deterrence Studies, where we are advancing peace, promoting stability, and helping you to think deterrence. Each week, we will discuss and analyze a recent topic and provide insight to how it affects our national deterrence. The view of the hosts and guests are their own. We hope you enjoy the show.
Welcome back to another great episode of the NIDS View, a podcast of the National Institute for Deterrence Studies. As most times, I am Adam Lowther, and Jim Petrosky and Curtis McGiffin are with me today. And, as is always the case, the views expressed by the podcasters are their own and not necessarily representative of any other organization. Now, we've got a great topic for today. There was an article in War on the Rocks, Beyond Human in the Loop, Managing AI Risk in Nuclear Command and Control by Alice Saltini and Yan Liang Pan from the James Martin Center, which, I think that's part of the Monterey Institute, if I remember correctly. And their discussion is essentially one in which they advocate that simply saying we're not going to, the U.S. and China, for example, are not going to allow, AI to make nuclear employment decisions, that there will always be a human in the loop making such decisions, that's not enough. And they advocate a risk model akin to what the civilian nuclear power industry uses to, effectively determine, is it a 1 in a million chance, a 1 in 10,000 chance, and then set a standard for what that risk tolerance is, and then create, you somehow effectively determine what AI usage, what that risk level is. There's if you input an artificial intelligence tool in this place, then there's a 1 in a million chance it'll get it wrong. But if you use it over here, if you use this type or that type, there's a 1 in 10,000 risk. And then once you figured out all that, those risk tolerances and risk probabilities, you then can determine what AI you can build into your NC3 systems. And not necessarily just AI, but any sort of advanced algorithms, because not all algorithms are artificial intelligence. So that's essentially their argument. Now, I thought, Jim, you build artificial intelligence tools for your own personal usage, so you're technically competent. And then as a guy whose specialty is electromagnetic pulse, rad hardening, stuff like that, I figured, risk tolerances are something that, you think about quite a bit. So I figured I'd get your take on this first, since you've got quite a bit of experience in the area.
Well, thanks, Adam. And I can tell by the way you're giving me accolades that you're set up in some way to throw some absolute unknown thing at me later on. And you're going to be surprised, and the audience is going to be surprised at some of my comments here, because in the show prep, what we had done, a little bit of the show prep, I may take a little different view than you and Curtis. So that's always good for the audience to hear. So I'll try to be concise, but good luck. I'm not good at it, but a few words, and I'm more and more becoming interested in this AI and a lot of the hair on fire kind of views on this. So let me throw out a couple other things for the audience to listen to, sort of to get things ready. I'm actually going to agree with Adam in one of the most contentious issues between he and I. But in the end, he's still wrong, but we'll solve that later on. And I'll say right up front, I'm actually generally have no issues with using a risk assessment model in the appropriate way. But I will say there's parts of this process that are not applicable to the NC3 that become problematic. And we need to look at that. So anyway, let's go back and look at what risk assessment model is. So for the audience, risk assessment models are typically, I think of an engineering tool for evaluating a process where you're looking at outcomes and you're trying to assess outcomes. And so you start out by saying, what are our risks? And in the NC3, everyone's, immediately says, well, the biggest risk is that someone launches a nuclear weapon and we don't know it. And by the time it hits the ground, it's too late and it changes our life. So that's just one of many risks. And in fact, I've always thought of everything as a process. A failure along any part of the process, the failure of a system along the process leads to greater risk. But in the end, you have to look at the end result. And then there's a question of probability. And this probability is really the issue I had for those that have been in the military or around especially the Army, where we build these, impact matrices and say, this is a red and this is a yellow and this is a green. That's one level of it, but then you can go into greater detail in details for that. And then you look at each of those risks and you say, well, what can we do to reduce the risk? And then you say, if this risk, if we fall out on the wrong side of this problem, this impact, and something comes through, what's the impact? And then we evaluate that by saying, okay, then I can only accept so much risk because the end result is intolerable. And use statistical means to do this. And this is where I have some issues. And so so that's the whole process. So I thought I'd lay that out for our audience and give them sort of the steps. And the end result is you get a quantifiable, a number that you provide. And by the way, for those of you that have done some of the work on analysis of systems, et cetera, everyone always asks, why 1 in a million? Why 1 in a billion? Why 1 in a trillion? Why 1 in 4? Why whatever? Oftentimes these numbers, they are difficult to come up with. And in the end, you know how they're made up? Someone comes up with a number that they accept and away they go. And they accept it for one of two reasons. They accept it because if you make it a really, really tight tolerance, really low number, then the cost for a project or a system would go out the roof. For example, you could say, I have zero risk. I'm not going to accept any risk. Okay, 100%. Well, good luck with that. How are you going to prove that? And what money are you going to put against it? And normally what happens, I go, well, okay, 1 in a trillion. Well, we can't do 1 in a trillion. We don't have money for that. Okay, 1 in a million. It's so I've seen these things go this way. And so there is a sort of a human factor always in this. And this goes to my agreement with Adam, because in a couple shows ago, we talked about the difference between engineering as a science and political science. I'm using air quotes for those looking science because here's the issue when we're talking with NC3 and really with a lot of other issues, and it's this human factor. Because when we talk about humans, you say, well, how do I know if I did this again, it would happen again? Well, as a scientist, when we're using a nuclear reactor, I can go in, I can create the fault again. I can go ahead and break the tool, the thing that was in the way, the whatever it was. I can test it and analyze it. I can break 500 of them and say 300 worked in this way and the others did not. And I can do all that. But with humans, you can't. You can't do that. We can't go back and refight World War II. If we could, I'd at least give Adam, say, well, now I have 2 examples in your statistical set because we've done it twice. But if you want a good statistical set, you're going to have to do, you have to fight 25 World War IIs to figure out what the outcome's going to be. And you can't do that. The second piece that I have here, we look at this risk analysis and then, of course, this risk control when it comes to people. And this is why working with people, Adam, is very hard. I agree it's hard. That's why it's not a science. You just got to figure it out some other way, because you can't go back and apply the scientific tools that I get to apply. And so I agree it's hard. See, I agreed with you. However, when you look at the risk, I can tell you, we can do this podcast today. In fact, for our audience to know, we're actually started this yesterday. We had some technical problems, and so we had to wait another day. So that was a risk in doing it. We just stopped. We started another day. But I can tell you, Adam is the same human being, well, sort of the same human being he was yesterday as he is today. But I can tell the monologue that he started with was different than yesterday because he's a human being. He's not a computer. He didn't read the exact same thing, wasn't exactly the same. And so things change with humans, and they are unpredictable. And that is a difficult part with NC3. The other piece of this, I'm going to turn it over to Curtis. I'm going to get back to some more of my monologue, but I think these are important points to lay out. The other piece that is really important here is when a nuclear, because they subscribe to the idea of using an engineering risk tool that is based upon nuclear reactors in the past. And just to give you an idea, what they do is they assess that risk. And of course, they say this is an impractical way to do this. But what is most important here is the nuclear reactor is not trying to thwart you. It has no sentient being. So it is going to react in pretty much the same manner, given some scope, some probability up and down, whatever. It's going to react the same way. Human beings aren't. If I was able to reach out in my screen right now and I'm poking Adam, now I'll poke Curtis since I poked it. If I poke Curtis in the eye right now, I might get a response. But if I poke him, if I go back in time and do it again, I could possibly get a different response. Humans have a different nature to them, and he's trying to avoid me. The nuclear reactor is not going to try to avoid me. And in NC3, our adversaries are trying to do something unpredictable in order to get around our predictability. And that's the problem that we have in using this tool in the wrong way.
Well, but Jim, the question though is when you look at creating a statistical risk model for implementing artificial intelligence tools, and in the article they use the word AI as sort of a blanket term for all sorts of things that have different levels of risk, different levels of error, but they use it. And my question is that the whole point of AI is that it learns. And so I don't know how you would create a numerical risk valuation for something that's learning and changing all the time. The more data it gets, the more it changes, and therefore the risk level, that numerical value, should constantly change, kind of like it does with humans, right? So I don't know how you come up with that number for an AI tool.
No, I absolutely agree. But there is value in looking at it. The AI can point out things or find things that you don't see because of nuances or whatever that the human in the evaluations. This is why I say don't throw the baby out with the bathwater. The process can be valuable, and we do much this process. I can guarantee in the NC3 development and modernization, I know, Curtis, I see you there. You're chewing at the bit right now. In the process, we already assess risk. We do a risk assessment at every component, and we evaluate every component as best we can. We look at the probability of failure of components. We look at how to reduce that risk. That's why we're modernizing, by the way. We're modernizing to reduce the risk of failure components that we can either not replace or have capabilities or below what our adversaries have gone beyond. These kind of things are important in it. So I don't see the process to me is valuable, but I don't think it is, the way the article relates it, the only thing. And in fact, I'm saving till the end. There's a couple things that I find in the article just egregiously erroneous. But I wanted to lay that out, that the process of understanding and learning is always a good way of doing this. And this tool could be useful, but I don't think it is the tool. So you and I are sort of in agreement on that. And you can always adjust a tool, or we're constantly learning. I'm going to sort of turn it over to Curtis because he's biting here at his microphone now because he wants to jump in. But I do want to. But before he does, I just want to mention the one thing I think is going to set the stage for the next piece, and that is that when you look at something, and I'll use 3 Mile Island as the example. And in fact, I went back to make sure I got my facts straight. But in 3 Mile Island, and let me back up. In the NC3 system, you have a detection system, an evaluation system, a command decision system, and a reaction system. All of those are separate. And I know you can break them down into smaller pieces, and I'm probably got the wrong names on them, but that's the way the system works. In each one of those, there's risk. And I want you to just relate this a little bit to 3 Mile Island. In 3 Mile Island, the reason that there was a failure is there was a valve that was open that was incorrectly instrumented and did not show what really happened. There was a mistake in there. So instruments can fail. was that instrument failure happens. The humans evaluated it incorrectly and took incorrect measures to do that. So the human in the loop actually made the mistake. 3 Mile, you wouldn't even know 3 Mile Line had existed if the humans didn't get in the way, because the computer systems would have done what was right because they thought about this in other times. And so although this wasn't AI, and I agree with you, Adam, 100%, the way this article is written, they use AI in a very broad sense, like any algorithm is an AI. And here, algorithms were designed to be able to overcome design failures, which is what happened. But the humans jumped in, shut off equipment, and evaluate it incorrectly. And that's what led to overheating in 3 Mile. And I'd suggest people look at that. My point is that AI or algorithms, computers are not always wrong, and humans are not always right. So putting them into either one of those buckets is not very valuable. So Let me turn it over to Curtis here. I think that's my biggest issue that I have every time we bring up AI. You can tell I get a little animated over this. Go ahead, Curtis.
Well, here with this controversy, if you will, with AI, you notice that the references to the risk are always to technology from the 70s, events from the 70s. We have the same issues with launch on warning arguments, right? And no one seems to take into account that those technologies were much more, or I should say, much less mature, and therefore could be more prone to spoofing and otherwise, air quotes, failure, however you want to interpret that. I'll argue that the technology today is robust and getting better. And and there are ways to look at this differently. General Cotton, the commander of Strategic Command, recently came out and made a statement giving support to utilizing AI in the nuclear command and control system, stating that AI can help give leaders more quote unquote decision space to ensure the entire nuclear enterprise stays secure. He said back in October, and also noted that General Cotton said that advanced AI and robust data analytics capabilities provide decision advantage and improve our deterrence posture. That issue about decision advantage is where I think AI really plays a role herein. And the two authors that we're talking about in their article, they state in the very in the third paragraph here, escalation risks can arise from altered decision-making dynamics, accelerating processing speeds that outpace human supervision, or insidious errors that can propagate undetected through complex systems. I like to look at this as the other way. Jim always accuses me of being the pessimist of the group. I'm going to be an optimist of the group here and say, I would argue that these issues can lower risk by using AI, by consuming much more amounts of information and data and that are well beyond human capabilities, and then to inform. We can argue automation bias and things like that. If we can, just because we see it, we shouldn't just believe it in that sense. But here's what I think the real motivation is. And this is really, again, goes back to, Adam, where did our two authors come from? What's their background? You mentioned the center?
The Martin Center. Yeah, that's one.
For non-proliferation, right? It's a disarmament organization. And so they're naturally going to advocate for anything they perceive that might inhibit nuclear progress, so to speak. And there was a piece that came out very recently from Bill Gertz in the Washington Times back in June of this year, where it noted that artificial intelligence will allow large-scale processing of sensor data that can track mobile missiles on land and submarines at sea, especially when combined with other new technology, such as quantum sensors, according to testimony to the Congressional China Commission. That could destabilize strategic deterrence by undermining nuclear survivability through allowing targeting of systems once thought to be safe from attack. And so the question here is is that AI may render systems once thought to be quote unquote invulnerable to being much more vulnerable. And this is due to that ability to process so much more data and be able to make the decision space that General Cotton is what I think was considering in his statement. And so this makes nuclear weapons maybe just a little bit more effective in the eyes of non-proliferators. So naturally, they're going to be nervous about this. I don't think there's anything to do with affecting rationality of launch decisions. When we read this statement that I just read, what this goes to is the idea that AI is going to decrease the mutual vulnerability aspect of minimalist deterrence thinkers who, under the Schelling model, want to rely on this idea that we must be vulnerable to attack in order to ensure deterrence. The problem with this logic today is that the adversaries don't share that. They've never shared that. And so we continue to pursue and argue ideas that make us more vulnerable purposely because of this incorrect thought that vulnerability leads to deterrence. Vulnerability is provocative. And what we need to be doing, and if AI is part of that answer, we should be embracing it, is how do we use it to make us less vulnerable? And again, as we all know, we want to reduce the danger to America. Danger is a mathematical equation of threat and vulnerability.
Yeah. So, Curtis, I don't disagree with that premise, but I would say the concept of using any kind of model to be able to evaluate and understand what's happening here is a logical piece, and we're doing it already. There are processes to do that. In fact, I want to take a couple pieces in this article that I think are really important, and part of the premise comes right out. You went to the third paragraph. I want to go to the second paragraph in this article that sort of highlights a little bit of the sort of hair on fire idea. And it says, avoiding a Skynet scenario where AI takes independent control of nuclear weapons. No one is advocating to put some pseudo AI in charge of everything and let it just run and let the computers talk to each other and they can figure out what's going on. No one has ever, in the history that I've seen, now I'm not around very much, but I haven't seen any article say, yeah, we just need to turn it all over to some computer. And in fact, if the computers are going to do that, I've recently begun to embrace AI for writing. My good friend, unfortunately, he passed away recently. John Emily opened my eyes to using AI to be able to start writing and to get paragraphs sort of sorted out and do emailing and stuff. No, I don't send you an AI email, but I do possibly use it to set up an outline to do that. But my AI hasn't gone to my computer and started writing letters to Curtis and Adam about how good they are and why they were wrong on the podcast or anything else. My AI is not doing that. Okay,
your AI has never once offered me a raise.
Yeah, there's a reason. There's a reason for that.
It hasn't resigned on your behalf. It hasn't told you. Have you seen the stories where AIs are telling kids to kill themselves and stuff?
Oh my gosh.
Well, again,
it's never told you, Jim, you should quit. You're not doing the job.
No, my wife's told me to quit. No, that's a different story. But not quit here, quit other things. But anyway, so no, but seriously, that is such a pie in the sky. And maybe there's something behind the scenes that someone's talking about. I like to start seeing those articles, but we're not talking about that. And then the second piece is, and you're exactly right, it has the promise of enhancing the performance of our systems. We should take every advantage of performance enhancing systems, okay, that will ensure that we work well. And I want to bring a couple of things here. In like the eighth paragraph. So since you point out numbers here, so in the eighth paragraph,
count down
first,
here.
yeah, that's right. Yeah, I got you moving there, Curtis. So one is first, AI is unreliable. Okay, and they said it generates false information, flawed predictions. They call them hallucinations. Well, let me tell you something. People are unreliable. The number of times I've gotten false information from someone that saw something and believed it was something, and it wasn't the something they thought it was. whether it's a deer hunter that sees a squirrel and thinks it's a deer, or, there's all kinds of things, these hallucinations. People are fallible too. So AI is no different than people. There is one piece here. The other one is the black box problem. This is an issue, although I'd say the black box problem. What went into the AI to get it to do something? What went into the person to do it? You go read the newspaper today, anything you want to read about an event. We had this horrible event of the CEO shooting. What programmed that person? You cannot say that was a reliable person. We don't know what programmed another person in that same circumstances as that presumptive killer had taken, may come out with a completely different result. Black box. That's people, not a problem. Okay. And then finally, they struggle to align output with human goals and values. And human goals, I think, are a little different here that I want to hit. And you're right. It doesn't take into account human goals, but it doesn't have all the emotional, in a heat of battle, the emotional problems that people will have. I mean, it's a tough call when you're talking about launching nuclear weapons, killing many people. It's a necessary. I'm not saying it's unnecessary or unneeded or invaluable, but it still is a difficult part. Talk to any soldier who's been in battle, anyone that's been in those situations, and they'll come back and they'll say, that was difficult, necessary, but difficult. And we would want that from humans. The AI takes that emotion out of it. I want to put one other piece here before someone jumps here, and that is that, well, two more actually, but one more is there is one issue with this AI assessment model that I do want to focus on. If we go to a quantitative process, the problem with us as humans is once we get a number, we tend to focus on the number. And if I tell you that something, I say you're wrong, you say I'm right, I say I can show you 99% that you're right, or you're wrong, or whatever. Once I put a number to it, people tend to use numbers in computers and take them at face value. And we've got to be very careful not to take things at face value. That's why humans are involved in this. And that is one concern I have when we quantify this, because people, will say, well, it's science and it has a number, so therefore it must be right. That's not true. We're seeing that with computers nowadays, where people will take a value that's numerical and apply it as though it's gospel. I'm a scientist. Everything only works within a scope, works within the ability to test and measure. There's always more to this. My last piece that sort of ties these three comments together. If you are really concerned in the disarmament community about an AI takeover of our launch system, I strongly recommend you begin to advocate for bombers on alert, because we have a human in the aircraft, we have a human on the aircraft. They're doing, because people don't make mistakes, right? So no mistakes would be made. We'd have bombers on alert. They'd be ready to roll. They'd be flying. They'd be doing all the work that they need to be doing. They would be there, all human driven. Okay, there would be no mistakes. Everything would be cool, and that's the way I would advocate it. Go ahead.
You guys have brought up, we're getting close to the end of the show, but I wanted to point out that for, you in particular, Jim, have pointed to a couple of things that I see as problematic. When you mentioned the idea of Skynet, which, if you read, this isn't the first article that challenges the use of what we'll broadly call AI, but it could be, algorithms that are not AI. It could be specific types of tools that are built a certain way, because different tool types have different strengths and weaknesses. There's no such thing as AI writ large. It's not one uniform thing. And what bothers me or concerns me is that people who are often writing about nuclear command and control know absolutely nothing about it. Mm-hmm. They don't understand. They have no image of, like when we were down in J33 and Opie Dawkins was mapping out the NC3 system and all connecting all those systems. We had a visual image of what that system actually looked like. And we knew what individual systems did. And so therefore, when we think about AI, we think about all of these various systems that do specific and discrete tasks. Whereas I'm not sure what these writers think about. I don't know what they think the NC3 system looks like. If it's just this,
I agree.
They think it actually is like a Whopper type computer. I don't know what they think it is, but whatever the way they describe it when they write, resembles nothing of what actual NC3 looks like. So that's a big problem when you don't know what it looks like.
And I don't necessarily say I take offense to it, but I will say people don't do their homework. This idea of, well, we just, stick a nuke on an airplane, send, a pilot and a bombardier and a navigator up in the sky, and they can do whatever they want with it. And I've seen some of that in the writing or the, back a couple months ago when people were talking about the nuclear football, and they're like, they were talking about the president tripping, and they're like, well, he could trip and fall and accidentally hit the button. Like, you really think people are that dumb? I mean, there's a lot that goes into this process in understanding this. So we get it right every time. And by the way, look at our history. How many times have we gotten it wrong?
Yeah. Well, so that's the problem number one, is they don't understand NC3.
Mm-hmm.
And problem number two is they don't understand artificial intelligence.
Yeah.
And because they don't understand NC3, they don't understand what types of tools would be useful on, embedded in specific types of systems, whether they're comm systems, whether they're detection systems, and so I never hear somebody that talk about, well, this specific type of a tool, of an algorithmic tool with this type of a redundancy could assist in this specific, let's say, like in the Missile Warning Center in missile detection and, determining what type of a missile, determining trajectories, things like that. Very discrete tasks. I never hear people talk about a specific type of a tool. Do I need random forest? Do I need, you're not going to use a large language model for that. That wouldn't be an appropriate usage of that type of a tool.
That's right.
And so you generally, I hear people, and then I go and I sort of look at their backgrounds, and they don't have any background in the development of AI tools. They've never been on, they're not, they don't have sort of an educational background in it. They've never been on teams, because to build really good AI tools, you need multidisciplinary teams.
You need data.
Yeah. Well, you need training data, but you need multidisciplinary teams that are not just the programmers. The programmers do one component of it. The data scientists do one component. But, like large language models, you need all sorts of social scientists and others. And I've never heard anybody say they've even been the social scientist on a team that built, Siri or, any other, sort of model of that sort.
Right.
So not only do they not know NC3, they don't know AI. And so then you combine a lack of understanding of NC3 with a lack of understanding of AI, and you get articles that are they're misinformation. They're not disinformation, because these people believe that they're accurate and they know what they're talking about. So it's not disinformation, but it is misinformation.
They don't do their homework. They don't do the homework. That's the problem, because they don't have an interest, as Curtis is sort of pointing to. Curtis?
Well, let me add to this argument here before we wrap things up. And that is that I think for these kinds of advocates, there seems to be a confusion that AI is some sort of end, when it is not. It is a means. It is a resource to be used to achieve an end, a goal, whatever it is that you're looking to do. AI is nothing more than a tool. And it's a tool, for this purpose of streamlining, these complex systems, complex data resources. It's just really good data analysis and decision support. You can control it and limit it. I mean, even in our author's paragraph number 7, that in principle, I'm quoting, AI's ability to analyze vast amounts of data from diverse sources is well suited to identify threats quickly, analyze sensor data, automate the identification of objects, and evaluate potential courses of action. Gee, that all sounds very good and stabilizing to me, because now what I can do is maybe my adversary won't have so much bounded rationality in which they're making emotional decisions and reactionary types of decisions without the kind of data that they should have. And so to me, these are stabilizing issues, not destabilizing issues. And that I think our authors really sort of misconstrue in that regard. The last thing I want to bring up here is this China question here. And that is, so just recently here in November, this past month, China recently agreed to this idea of AI not being engaged in NC3. This just came out here.
They won't make decisions. The U.S. and China agreed that they will not allow artificial intelligence,
right,
to make nuclear decisions. That was sort of the tentative agreement.
So the tentative agreement, which came out on November 17th after some sort of agreement between Presidents Biden and Xi, was that the two leaders stressed that the need to consider carefully the potential risks to develop AI technology in the military field in a prudent and responsible manner, the communique added. So this was beyond just nukes. Mm-hmm. And that Washington has been, and it noted, the article noted here from, it was published in Reuters and CNBC, that Washington had been pursuing Beijing for months to break a long-standing resistance to nuclear arms talks. I think it's referring to this idea of AI. What does that mean? Well, back in September, the Chinese once again refused to sign an agreement to ban AI from controlling nuclear weapons. And this is a carry-on from June, where they once again told President Biden, we're not doing that. We're not going to ban AI. So why the change all of a sudden? Did America's election have anything to do with that? Is there some sort of desire now to constrain American AI development now that they have theirs?
Yeah.
And so it is never a good thing for our adversaries to have and utilize technology that we refuse and self-deter ourselves. And that is not stabilizing, listeners. There is nothing stabilizing about our adversaries having a capability that we refuse to use and harness. And so we need to figure out right ways to do this. Constraining ourselves in any sort of technology that defeats our ability to provide effective deterrence and places fear in the adversary so that they will not strike first is only going to disserve the American people. And I think calling it out is what we need to do.
Well, unfortunately, we are out of time, Jim and Curtis. We've gone.
Oh, I have so much more to talk about, though.
Well,
this is a real exciting topic, and I'm glad we're approaching it.
Apparently, this was the Jim Petrosky show today.
You got it.
I mean, but I'm going to cut you off because we are out of time, and we are a drive time show. That's our whole purpose, is to
It's wintertime. People drive slower. I got more to say.
Well, if there's snow on the road, they'll listen to the last 7 minutes. So, that's that'll be good. But it's a good topic. Thanks, Curtis and Jim. It was a great topic for today. It ended up being, drawing a little more of that human excitement than we anticipated it would. But it's a great discussion, and of course, hopefully, the listeners followed and thought it was as interesting for them as it was for us.
Adam, I have a really important thing to say to our listeners. If you're interested in making a tax-deductible donation to NIDS before the end of the year, time is running short. So we have the ability to do that at thinkdeterrence.com. And it's a great opportunity for you to support things like this podcast or the many other events that we do. And I know I don't normally push this to our listeners, but, it's time. I'm looking at my tax deductions and I know where my money's going to go. And so if you want to do that, reach out to us at our public page at thinkdeterrence.com. Back to you, Adam.
All right. Well, thanks for that. $1 million donations are always welcome. And anything below that as well.
We're happy to name this podcast after whoever is $1 million donor. That's for sure.
You got it.
Yeah. So, of course, hopefully everybody enjoyed the show, and always want to remind you, check out Global Security Review, where we're publishing interesting articles on Mondays, Monday, Tuesday, and Thursdays. We publish a new interesting article on those days. Curtis tweets every day some sort of really interesting thought with an interesting article. And then there's, QC events, all kinds of stuff going on. There's Deterrence Down Under, another podcast. There's Real Space Strategy, another podcast. there's just always stuff for you to engage with. So please do that. And of course, as we wrap the show up, we always want to remind you to think deterrence.
Thank you for listening to the NIDS View. This show is produced under the NIDS Podcasting Network, a division of the National Institute for Deterrence Studies. NIDS is a 501c3 organization dependent upon donations to provide this podcast and bring about awareness of the peacekeeping value of U.S. strength and our national deterrence. You can catch all of our podcasts or provide feedback at thinkdeterrence.com. I would like to thank our producer, Kimberly Charrington, our sponsors, and all the fantastic members of the National Institute for Deterrence Studies for making this podcast possible. Stay tuned next week for another exciting and informative The NIDS View.